I can't. I was going to rip on another class. Anyway. Hi, everybody. All right. Okay, so vertical asymptotes, what are they? Well, we better make sure that this doesn't factor and cancel, because then that would be a what? Oh, right? So does this factor up in the numerator? I think it might. Like, isn't that true that that's the factorization of the numerator? I just asking, is that the factors of the numerator? Isn't that what the numerator is factored? Okay, come on now. All right, over x plus 2. So do any of these cancel? No. So what's the vertical asymptote? No time. X equals negative 2. What's the horizontal asymptote? There isn't one. Why? What's the degree of the numerator? Higher than the denominator. So what we're going to do off to the side after I find the intercepts is find the slant asymptote, and then I'm going to show you in the graphing calculator how the graph behaves towards that. But what are the x-intercepts? No time. You plug in 0 for y. This is the last time I'm going to show this. What actually happens to the denominator when I cross-multiply? What happens to the denominator? Cancels. And then you get the numerator equal to 0 when you're finding the x-intercepts. And then seeing that this is in factored form, what is the x-intercept? It's just one x-intercept, which is what? 1, 0. Because we can see this in factored form, x minus 1 set equal to 0, and solve, you get 1. 1, 0. 1 for x when you plugged in 0 for y. What's the y-intercept? I'm not writing that down. You plug in 0, 0, and 0 here. What do you end up with for the y-intercept? 1/2. So you'd all be marked wrong for saying that, though, because it's 0, 1/2. Did I say good afternoon? All right, so 1, sorry, we got to write everything down now. 1, 0, 0, half, and then x equals negative 2. Where are we at? Sorry, I got lost there for a second. There we go. And then no horizontal asymptote. All right, now watch what happens. This is crazy. To get a slant asymptote, even put that down here, you divide physically the numerator by the denominator. But we can use the glory and power of, don't say logarithms. Synthetic division. I know I use that for logarithms a lot. Synthetic division. What number goes in this little thing? Negative 2, and then what are the coefficients? No time. Okay, bloop. Bring down to 1, negative 2, and negative 2 is negative 4. 8, right? And then who don't I need at all? The slant asymptote is y equals 1x minus 4. All right, now what stinks about this is my grid is not really going to show this really well. I'll go to my graphing calculator and we'll have to make some adjustments. So watch this. In the Y1 screen, I'm going to put this graph. In the Y2 screen, I'm going to put the slant asymptote. And that's how we're going to close off at least this part of the notes. So, clear? All right, I need parentheses. Stop making that mistake. Rough. X squared minus 2x plus 1 divided by, stop making this mistake, x plus 2. No parentheses, not even close, Chiefs. Clear? X minus 4. Actually, let's look at the graph first. Ah, look at that end behavior. The end behavior is not horizontal, it's slanted. But you know what's missing? You're missing a key component of this graph. You're missing another part. You know what you have to do? You have to adjust your window. And actually, I know where the part is, because that slant asymptote goes down negative through quadrant 3. So another part of this graph is in quadrant 3, which requires that I manipulate my y minimum. So I change my y minimum to negative 50. This will, see it? Do you see it? Now, it really distorted the way that graph looks slanted-wise because I distorted the window. But watch when I go back up here and I put the slant asymptote in y2, x minus 4. Graph. What does it look like that graph is doing to that slant asymptote? Approaching, but what? Not crossing. And guess what you have right here, which you already knew existed. What's right there? The vertical asymptote. So if you were just to graph this on this grid, I would have to be mad and mark you wrong. 1, 1, 1, 1. This is an asymptote, so this is what you'd have to do for me. You have to draw this horizontal asymptote. Wrong. This slant asymptote. Show that the graph does this, and then I got to erase my x-intercept. You see these these asymptotes crossing here and here? At least show that you know the other part is in there. You got me? All right, now it looks distorted compared to what I had there because this window is in more standard little position there. But if you're missing this part on a slanted asymptote question, you're done. I'm going to get you. Okay, I zoomed in on number 6. Sorry for all the other red writing there. I don't want to zoom in too much more. Okay, the numerator, factors, to be x plus 1, x plus 3. The denominator, tough factor. You'd go through it. I'll just give you the answer. You go through your factoring of trying to figure it out, the unfoil, it's 2x minus 7x plus 1. As of yesterday, you would have said there's 2 vertical asymptotes, right? There's not, because one of the x plus 1s cancels with the other one. So what is that negative 1? Not a vertical asymptote, a what? How do you get the whole? You take this negative 1 naughty value, and you actually plug it into the leftover. All right, and then that's how I get this negative 2/9. So when we go to the graph and we actually graph these tomorrow, at this spot in the graph you will have a hole, an interruption, and that's what you need to know. But there still is a vertical asymptote here at x equals 7/2. So that's what I want you to do in this first section. Try to get the vertical asymptote and hole idea exercised and figure. Same thing. Here's number 18 in that next section. You're required to factor. Still moving, isn't it? Factor. Stop moving. Factor. And then see what cancels. So I'll help you on the factoring on 18. So yesterday you would have said 3x plus 2 and x plus 5 both made vertical asymptotes. Wrong. The 3x plus 2's cancel. Now here's the idea. Negative 2/3 is still a naughty value in the original. Negative 2/3 when plugged into the original function gives you 0 over 0, which is what? But 0 over 0. Still undefined. So what you have to do is show where is that bad point in the leftover graph. Okay? So what you have to do is take negative 2/3, and you might want to use a calculator on this. You plug it into the 2x minus 1 over x plus 5 leftover. That's a hole. Whereas x plus 5 still gives you a vertical asymptote at x equals negative 5. So get that wax on, wax off figured out on the front of this worksheet. On the back, go ahead and graph those two. That should not be an issue.